So for me, I am going to take attendance based on who's here and who's logged on. So I take attendance after class. So like during ACE, what's going to happen is I will get, like I'll obviously know who is here, and then like Google Meet sends me like my attendance list. And so I just check that. I just make sure you showed up on time. So it doesn't bother me how you access the class as long as you're doing what you need to do. But that's me. So teacher to teacher, I think that's going to change. But for me, I don't care as long as you're here. Cool. So first things first, how's it going? How is it being back? Is it all right so far? Like, I mean, obviously it's different, and I don't know, some teachers are doing things a little bit differently. I've got these guys at home. I got you guys here, so I'm going to try to do my best. So let me know what's working and what's not, right? I'm going to try to teach the same way I've always taught, because I feel like that works for a lot of us. And but let me know. You just got to give me a shout if something is not working for you, okay? Whether it's like you're in class time or you're at home time, because like they're like in my ear, so they can hear us, but you can't hear them. Because if I turn, so I'm also logged on there just so I have a better view of the board, so I know what I got going on. But if I turn the sound on there, you would hear me echo because like I'm logged on to Meet there. So I don't want to do that. I keep the sound off there. But so if I ever like go like this, that's just like me like letting you know that I'm talking to them. Like so I'm hearing in here, so I don't seem too crazy like I'm talking to myself. But hopefully things are going okay, that the return has been good. A couple things I just want you to remember kind of going forward this week. Like we still have homeroom. So cohort A, you guys are going to be like in your homeroom on Wednesday. So right after fourth, you'll go to whatever that homeroom class is that you guys have. I don't know what the plan is for homeroom, but it is necessary for you to get enough hours to graduate. We wouldn't have it if we didn't have to have it. Okay. So just keep that in mind for the next time you guys are here. Is that a question, or are you just picking? Okay. Cool. So that'll kind of mess with our timing a little bit on Thursday. Just remember that the class times are, or for Wednesday, sorry, the times are just a little bit off when it comes to that. And I want to try to make this work, but there's no guarantees. What I want to try to have happen is that like you guys don't always have to see like one side of this class, like always like the lecture side or always the practice day. Like I want to try to like mix and match those up so that you're getting kind of both sides of everything. But that's just going to happen the way it happens, right? So you guys might get like 3 lectures in a row, and then cohort B might get 3 practice days in a row. Just however it works out. Okay, I don't intend for it to work out that way. I actually intend to try to make it not work out that way, but it's just going to flow the way it flows. All right. But what I want to do, because I think it worked last week, is kind of keep the same model that we do at 2.3 and kind of attach it to these last 2 sections so that we can knock these 2 kind of like recaps, reviews, like get those done, and then do like a quiz for just effort and completion, just like we did. It's like to give you a chance to try this stuff out, but really get you some good credit for it, and then one for correctness. Now, whether that happens here, happens at home, or some combination of both, it's whatever happens, okay? So be flexible and let me know if you need anything. I'm happy to make it work. But let's just get down to it. I want to switch gears. We did factoring. Factoring's good. Take out something to write with, something to write on. Let's go back to 2.5, which will seem a little bit more familiar than factoring did. But like I went through quiz 2.3a and it was really good. But remember that I went through and I tried to give you as much feedback as I could on like kind of your first try through it, so that when you got to your second one, maybe you had a chance to make the adjustments and kind of do whatever you need to do there. So hopefully that worked out all right. I don't know if the folks at home care that, so they can see us if you want to wave and say hello. It's just nice to be able to to see you guys. So, all right, let's do it. So what we did in 2.5, I think was the hardest one. I think it's kind of like the most work. It's the less intuitive. It's the one that feels like it takes like 3 different steps. And so it's not my favorite by far, but it is kind of nice. And so I want to make sure that I recap it, but I feel like we might be able to get far enough today that I can get like the first like quiz, call it like quiz 2.5A, like I can get it out to you maybe even today. Like we can maybe even start it in class and then it'll just be due tomorrow. So let's see how far we get. But what we did, not factoring, we did the vertex form one. So that we did find the x-intercepts using vertex form. Right, where it starts one way, but like we don't like the way that that equation looks, right? It starts like ax squared plus bx plus c equals 0, and this is where we actually have the equals 0 in there now. But like it's just not factorable. The numbers just don't work out. The diamond problem doesn't have any answers, or the blanks, however you like to do that. And so instead, you just change the way it looks first, right? We change it to that, and hopefully this rings some bells. The ax minus h squared plus k equals 0. And folks at home, I know that there's a glare somewhere, so let me know if I'm writing in it, if you need me to repeat anything. But you're just going to have to unmute yourself and just give me a shout. And so there's got to be something that happens in between there, right? We have to make the first one look like the second one. And we figured out how to do that. Like we figured out how to. And it's really about finding the vertex first. Because if I can find the vertex, that's really all I need, right? Because the vertex, that's that h comma k. A is just A, same numbers. I don't have to worry about changing that. It's just that B is not the same and C is not the same, so I had to find that first. And so let's do that. All right, we found H using like some combination of A's and B's and C's. Yeah, that's okay. So I'm not muted here. This is the camera that's streaming. I'm not muted here. The Bluetooth is picking up the mic. Yeah, so that's why I can move around and stand over here. But thank you. I appreciate you looking out because that's important. Does anybody remember that super nice shortcut, Ken? Nice, perfect. Negative b over 2 times a, or just 2a. Now remember that negative sign really just means change the sign. If it starts positive, cool, make it negative. If it starts negative, we'll just switch it back and make it positive. Cool, so now we know a because it's the same a. We can find h by just plugging some stuff in. Do you remember how we get the y value that goes with? Because that's x, right? H is just the x value of the vertex. K is the y value. So let's say like h is 2. Okay, cool. Like what do we do with that? To find the y that goes with it. Yeah, they gave us the whole equation. Let's just use it, right? Plug in h and just see what you get. So let's just try it. Let's just jump into one. Let's go for it. Example 1. Let's see, do I have to move over? Yeah, I'm gonna scoot over. So hopefully folks at home, I'm gonna make a scoot. Let's move you a little bit. All right, again, give me a shout if you need me to repeat or say anything. Let's just make one up. I don't care. So f of x equals, and let's start simple with just x squared and not like 2x squared or 5x squared, anything like that. Plus, I don't know. Colton, give me an even number. Huh? 4 or 4D? 4. Okay, I like that one. So 40 is humongous. No, give me a number. Just make it negative. Negative 7. Cool. Awesome. So there it is. And so I always, like, I got to set it equal to 0. I want to find some x-intercepts I probably should have said that from the beginning, but that's all right. So x squared plus 4x minus 7 equals 0. All right. So I don't like set it equal to 0 first. How about that? Now, if this thing was factorable, super easy, way easier than trying to go through this whole process. But two numbers that add to 4 multiply to -7. The only way to get to 7 is 1 and 7. I'm never going to be able to put those together and get to 4. So I don't expect to get really nice answers here, but it doesn't mean I can't find them. If I could figure out what A is, so I'll do like my A equals B equals C equals kind of setup over here. A is going to be a number I'm going to use, and then I'll just find H and K by doing a negative B over 2A, and then we'll plug it in. So what's A if we don't write that number in front of x squared? Good. 1 x squared. B, the 4, and then what's C? -7. Good. Don't forget about the sign in front. It's going to make a big difference for us. And now, so you can see how, like, I kind of like stacked these right on top of each other over here. I want to be able to do that. I want to like work straight down over here, but I have no idea what the vertex is yet. So that's usually why I'll like slide over to here and like do some side work first. Or I'm going to figure out whatever H is by doing that whole negative B over 2A. And then I'll find K by plugging it in. Then I can go back. All right, so B is 4, so -4. Okay, cool. So just switch the sign. And then 2 times 1. All right, that's just 2. I'm good to write that. If you want to put 2 times 1, that's okay. So let's make this work a little faster for us. So that's -4 over 2. And that's perfect. Nice, -2. There's nothing I have to worry about. No fractions, no decimals, nothing weird about it. But even if it was, I would just do it. It's fine. Numbers are numbers. I'm just going to roll with it. Cool. So I know I got to use A. I know I got to use H. Now let's find the K that goes with it. And that's what the whole function's for, right? Plug in any X you want, and it'll give you the Y that goes with it. So I'm just setting that up right now just so you can see that everything stays the same, except instead of X, we're just going to plug in a number, whatever it is. And we got -2, so that's the one we're going to use. -2, -2. And I cannot tell you how nice it is not to have to show every single little step here with all that arithmetic. Calculators for sure. Like every time we do stuff like this, have a calculator out ready to go so you can just type that whole thing in. And I don't even use my phone's calculator anymore. I use a better calculator app. I just think that they're way easier because they can like change decimals to fractions. They can like do all the trickier stuff that maybe my other calculator can't do. But that's -11. 4 minus 8 minus 7. And now I just write it like this. Now, you don't have to write this step where you like don't put any numbers in just yet, but I wanted to line it up right underneath so you can see where all of those numbers are going to go. Okay. A is 1. Okay. And I'll just put it there just for good measure for now. X is X, because that's what I'm solving for. Remember, we're trying to get like whatever I end up doing, there's my answer, right? X equals something. Finding the x-intercepts, I better get X all by itself. Okay, so now X minus whatever H is. Okay, A, parentheses, X minus H, -2. Don't put them next to each other like that. I combine those two negatives to be a positive. It looks just so much easier, right? So if your signs are the same, they combine to a positive. If the signs are different, they'll be negative. And then same thing here, right? So, okay, parentheses squared plus whatever K is plus -11. Are not two signs next to each other like that? No. What can we combine those two? A plus and a minus. Well, that's just negative, right? -11, just like the answer was. And so if it helps to write that step with like the A and the X and the H and the K, like without the numbers in, do it. Or you can just jump right down to here. But do we need this one? What is it? I just put it there to show you that it's there. But multiplying by 1 doesn't change anything. So let's save ourselves some trouble. Okay. So what did we do just right? We let's just say write in vertex form. All right, plug in the A, the H, the K, see what you get. Okay, cool. Now what? Well, like, what was the whole point in doing all that? Why did we get ourselves to this step instead of this one? Why does this one suck and this one's amazing? It's kind of the question. Like, why is this useless, but this we can actually do something with? Knowing that this is what we're trying to get to. We want to get to the point where we can get ourselves to x equals. All right? Found H, found K, wrote it down. Now what? What do you mean? Well, it's in vertex form, so that's good. Well, what's so good about it? Well, so I want to turn this, like with the whole x plus 2 squared, I want to turn it into this. I want to do some stuff to make it look like this. Yeah, right? And the thing that makes this possible, like how many x's do you see in that whole equation right there? Then go get it. How many x's do you see in the original? That's the problem. We started with 2. I can't do it. If I only have 1, now I can solve. And the way that we figured out back in chapter 0, way back in the day, if you were here in August, is that we can solve by undoing what's happening to x. Starting at the bottom. Start with the simple stuff, right? Any addition or subtraction, it's all by itself. So let me ask you this. Can we subtract 2 from both sides and get that x plus 2 out of there? Can I subtract 2 from this in here right now? No, it's trapped, right? So I can't do any addition subtraction if it's kind of stuck inside something bigger. But what about the minus 11? Can I add 11 right now? Then let's do it. Plus 11, plus 11. So now we're actually finally able to start solving for something. Like all of this like prep work was all leading to this point right here. Once you get to here, now the question really starts. Okay, now I can actually solve. Now I've got an equation that only has one x in it, and I can do something with it. Sweet. It's about making the left side simpler, and the right side is just going to get more complicated as we start moving stuff along. Sweet. Okay, so I did addition, subtraction, whatever I could. So in my mind, I kind of check off that level and say, all right, I kind of did all I could. All right, what about multiplication and division? Well, is there anything being multiplied through x over here or divided? No, you just have like a plus 2 and you've got this. It's because that 1 we didn't bother with, right? If this was a 2, okay, cool, I'll divide it. If this is a 5, okay, fine, I'll divide it. But we're good. If a is 1, you don't have to worry about dividing away 1. Not going to change anything. Okay, now exponents and roots. And so what's the opposite of squaring something? Square root. And so that's what we'll do in this step. We'll take the square root of the left. And when we take the square root of the right, don't forget that plus or minus in front. When we square root, use plus or minus. Now, I don't have to put it in front on this side because it's about to cancel out anyway, right? Square, square root, they're opposites of each other, so those are gone. So I just have x plus 2. I don't even need the parentheses anymore because it was just squared was the only thing connecting on the outside. And then we stop and we check it. Square root of 11. Is that good or not good? No, because like 3 squared is 9, 4 squared is 16, 11's in between 9 and 16, so that's no good. So what's the best way to write the square root of 11? That way right there. Now, what we could think about is whether or not we could try to simplify it. Remember what we did like week and a half ago? I showed you how to simplify square roots. You don't have to. You don't have to. I just wanted to show you how it was done. But nothing goes evenly into 11 anyway. So not every square root can even be simplified. So we're good. I like plus or minus square root of 11. Sweet, done. Okay. Love it. Now, look what level we're at. Right? Grouping. It's PEMDAS, right? GEMDAS, GERMDAS. Grouping. Look where I'm stuck, right? X plus 2. I'm finally inside. Now I'm back inside, and now I can kind of start from the beginning and go through that last bit where I can finally subtract the 2. I'm going to come over here so you guys can see it a little bit better. Maybe. I like to put the nice stuff first. Put that -2 before the plus or minus. Now, if you put plus or minus 11, -2, it's fine. Right, you write it in the order, kind of like we wrote it going down that way, that's fine. But we usually put the nice number up front and then the not so nice number second. Does that come back to you at all now that you've seen it again? I know it's been like 2 weeks since we've done that. But is that process okay? Do you feel good about it? I know, not the most exciting thing in the whole world. But what I want to do is I want to show you what happens when we have like A being like 2 or 3 or 5 or something else. Just so you can see that multiplication and division step, but nothing else changes. It's the same thing. It's my least favorite one. It really is. Quadratic formula is nice. It's already x equals, so just plug in the number. Factoring is super nice because it's the easiest. This one's just kind of the in between. So I want to have this happen kind of relatively quickly, and then we'll go back to quadratic formula. But if you guys are good, I'm good. I just want to do one more where A is something else, and then I'll probably have some time. We can start your work for tomorrow, because then you can knock out as much as you want, and then your tomorrow gets a whole lot easier. So we'll just kind of go from there. So here we go. I'm going to erase that, I guess. I'll keep that up. But I am going to move you guys home so you can see the new one. And maybe I'll have you guys help me make this one. All right, let's do it. All right, so we did f of x for the last one. I don't know, let's call it like j of x. Who cares? Example 2. Stick some numbers. Emma, give me a number that's just not 1, but make it kind of small. 5x squared. Let's see. Brendan, give me a number, make it negative, and make it bigger than 10. Negative 12. I need a little minus here. Ken, give me a number, make it odd. 5? Is that going to work? I think that should work. Cool. There we go. Let's see. 2 numbers add to -12, multiply to 25. 1 and 25, 5 and 5. That's what I do. Okay, cool. Now look, that looks real good. Now again, none of this process changes. The only thing that we ever have to worry about now is just doing that division when we drop that 5. Because remember, A is 5. What's B? What's C? -12 and -5. Okay, cool. Thanks. Write those if you like to. You don't have to put the A equals B equals C equals. But what I do like about it, though, is I like to be able to say, hey, I'm going to use that one. And I circle it. Because I know I got to use A, H, and K. Because I can't set this thing equal to 0 and do anything with it. This is not factorable. But if I can make it look like this, then it will be solvable, at least. And so I got a little side work to do. We got to figure out H, because that's first. Negative B. Well, B is already negative, right? So make the switch. Let's go back to positive. 12 over 2 times A. Okay, so 2 times 5. Okay, so 10. Well, all right. 10 doesn't obviously go nicely into 12. 12 and 10 are too close together. So what can we do? Any ideas? Should we just leave it? Let's try to simplify. Now, if you had a preference, fractions or decimals? Some fractions, some decimals. Pick whichever one you want. As long as that decimal has an end, you can use it. So let's start with the fraction version. Can we at least simplify that? What does that simplify to? Because they're both even, so I could divide them both by 2. So that could work. Or like just plug in 12 over 10 in your calculator. You'll get 1.2. Use whichever one you want. Quick poll from you guys here, because I'll just do it the way the majority picks. You want 6 over 5? Raise your hand if you want 6 over 5 compared to the decimal. Majority, there it is. All right, we'll do 6 over 5. Cool. Let's find K. Now, that means big time. Calculator, I am not going to let myself sit here and agonize about trying to do this in my head or step by step with arithmetic. No way. So you gotta jump into a calculator and you just have to sit there and type it out. And to drive that point home, I'm going to wait until one of you does. And we'll see how long it takes. Just as it's written, fractions are just division, so just type 6 divided by 5 once you get there. That's okay. I know you're feeling the pressure. But again, like, you don't have to do this stuff out by hand, because this would take forever to do that. And like lots of ways to make mistakes if you tried to. Like, oh gosh, doing this in my head. Negative, exactly. Negative 13.4. Perfect. Okay. Whew. Okay. All right. It's nice that we got a decimal we can use too. And feel free, like if you use a fraction for this one, but you have the decimal for this one, it's okay to intermingle them. It's kind of nice to be one or the other, like all fractions or all decimals. It doesn't make a super, super nice fraction, but it is what it is. Just for good measure, let's see. 13 times 5 is 65, 66, 60, negative 67 over 5 is what that would be. And so I'm going to actually end up using all fractions, or you should use all decimals. I don't care which one, but pick a style and go for it. Okay, cool. Oh, yuck, right? Now we just made up the numbers, so it's going to happen. But they're just numbers. So don't let the fact that it's a decimal or a fraction throw you off. We're just going to let it, we'll just roll with the process. Why not? You should have seen the one I did during 5th, or 6th. Nasty, because we just made them up. That's all good. All right, so A is 5, because that number goes right there. Parentheses, x minus, I'm just copying it all down. And the only thing that doesn't change is x, because I got to have something to solve for. All right, you guys want a fraction, so let's do fractions. So 6 over 5. And it's x minus 6/5, so I don't have to worry about like the double negatives or anything like that. Okay, cool. Plus negative something, so minus 67 over 5. Now maybe you wrote 1.2 and 13.4. That's fine. Either one's good. Let's see if I can mix in at least a little color here. All right, sweet. All right, so the problem finally begins. Whew, gosh. All right, now we can solve. So here's part A, part 1, right? There's part 2. There's part 3, and now we can actually go through this process. Again, let me back this up a little bit, because this is all I'm going to do, right? I'm just going to start working from down here, see what I get, plug it in, move stuff around. Sweet. Add whatever this is. As nasty as it is what it is. Those are gone. Put the line if you like it. 5x minus 6/5 squared equals 67/5. Hope I did that right. 5 times, yeah. Cool. So addition and subtraction done. Yay. Now what? Do we have something on the same side as x that's being multiplied through everything? There's a 5. So divide it away. It's actually kind of nice that it did work out to be a little gross, so I can tell you a super easy way to deal with fractions like this, because 67 over 5 and then make that 5 times smaller? Ooh, geez. Well, let me ask you this. You don't have to write this down, just take a look. Which number is smaller? 1/2 or 1/10? Which one's smaller? How'd you know that? There's 10 pieces and I only want one of them instead of 2 pieces and I want one of them, right? The 10 is bigger than the 2. And so if I want my fraction to get smaller, I'll make my denominator bigger. Makes sense? I'll leave the top the same, right? So, what number is smaller? 10 over 2 or 10 over 10? Well, that's 5 and that's 1. This is still smaller. Which one's smaller? Still this one, right? As long as the top's the same, I can make my denominator bigger, which will make my numbers smaller. So check this out. I want to take this weird fraction and make it 5 times smaller. Well, if I want to make it 5 times smaller, then let me make my denominator 5 times bigger. I'm going to leave the top the same and do 5 times 5 and get 25. Now, the calculator is going to back all that up. So if you did 13.4 divided by 5, you're going to get whatever decimal that is. If you type it in as a fraction and you change it back to a fraction, you just get that. But it is a super nice, quick trick if you know it. You want to make numbers smaller, make your denominators bigger. All right, cool. Let's take a square root. Square root x minus 6/5 squared equals plus or minus, whatever, square root of this nastiness over here. We'll just leave it like that. Nothing else we can really do with it. Like maybe there's some simplifying that we can do, but again, you don't have to. The simplifying is going to exist kind of on its own separately. Okay, cool. Square the square root, cancel each other out. I'm going to move to here, if you guys are cool with that. So x minus 6/5 gross, whatever, big square root, some fraction. I don't worry about the numbers, I worry about the process. Okay, so just subtraction done, multiplication, division done, exponents done. And now I'm inside. Now I'm ready to go. I'll just add 6/5. Again, you can, if you like the 1.2, go for it. On, see, x equals, finally, that's what I want. I know I'm done. Gotta write it nice. 6/5 plus or minus square root of this. And it's only so gross just because we made it up. I will make sure that whatever numbers I choose, if we do end up with fractions, they won't look quite like that. But we're just fractions, it's decimals, it's all good. They're just numbers. Question? Sure. Just go. Go for it. But that's it. That's all you need to be able to do here. Basically today, tomorrow, and then Thursday. Now, or Wednesday. Wednesday, right? Yeah. So this Friday, we don't have school. It's a teacher work day. It's a PD day. So you don't have to like log on and take your attendance and get anything done on that day necessarily. And then we have Monday off. Right, Monday is what, President's Day, I think. And so you guys, cohort A, next week, you guys come in Wednesday and Friday instead of Monday, Wednesday. Okay, that was a surprise. We did not know that that was going to happen until Superintendent Wise sent out that email. So just want to make sure that I relayed that to you. It only happens twice the whole semester. It's like next week and then April sometime. We have a Monday holiday. So okay, so here's what I want to do. I want to give you a chance to get started. We got 15 minutes. Let's make our tomorrow easier by getting some work done today. So that's what I'm going to do. I am going to, I'll leave that up just for a second. I actually already put it together. So folks at home, you're going to get a link dropped in to the chat. And then I will write down the same problems, but call it quiz 2.5A. I'll leave that. I'll leave this. And we should just get started. Now, this is going to be on Canvas, just like all the other ones have been. But this is not due until tomorrow before midnight. Okay, so find the x-intercepts using Vertex Form. One, 2, 3, 4, 5. Yeah, sure. Again, you have today and tomorrow to work on this, so do it at whatever pace works for you. F of x, g of x, x squared plus, yeah, that's x squared minus 2x minus 6. So 3 when a is 1, and then 3 when a is just different. X squared, h of x squared minus 3x minus 1. Again, you don't have to copy all of these down. This will be on Canvas for you to finish on. So you can just kind of work on them one at a time. I don't want to keep doing that. T, P, and A. T of x, P of x, A of x. 2x squared plus 8x minus 9. X squared plus 6x plus 1. 4x squared minus 4x minus 6. Sweet. Yeah. Sure. Sure. So I don't care if you start someplace fresh or if you just want to kind of keep going with what you're doing. You'll just kind of upload this to Canvas when you're done with all 6. First 3 like example 1, second 3 like example 2. I made the numbers work out a whole lot nicer though. They shouldn't be quite as bad, but still some decimals, some fractions might work their way in there on 4 and 5. And I'll say this again when everybody is back, but for tomorrow, you just have to check yourself in for attendance. You don't necessarily have to stick around cohort A. Cohort B, it'll be a great chance for you to just come in and knock these out. So don't feel like you have to have these done, cohort B, at home right now. Don't feel like you have to have these done when you get to class tomorrow. You can save these for class tomorrow. Or, you know, get done whatever you can right now, but don't feel like you have to do anything else outside class time. So cohort B, if you want, you guys can head out. You guys are good to go, or stick around and knock a few out. But I will see you all tomorrow. Here.
Thank you, Rosie.
You're welcome. See ya. I wonder.